Alright, in this video, we're going to find the area of Shrek's face. Well, kind of. Why do I mean kind of? Because the curvature of Shrek's head is really hard to define with a function, but let's just pretend and say it will be defined by this function here on the left. Yes, I know, this cursed image of Shrek. Oh my god. It hurts me just to look at it, but let's just pretend that the curvature of Shrek's head is represented by this function, boxed in green. Y equals negative 1/5 x squared plus 5. And we're going to evaluate it from negative 4.472 to positive 4.472. Well, why do we want to do that? Well, because as we know, to find the area underneath the curve, we have to find the integral of a function, right? And the integral gives us the area underneath the curve. So if we integrate this function over here, it'll give us this entire space underneath the curve. But if we didn't have bounds, we would keep on going and going, right? So we want to stop at some point, and we're gonna stop when our x value starts at negative 4.472, and we're end at when our x value hits 4.472. So we don't go on forever. So then doing that will give us this whole shaded region, which is the area of Shrek's face. Alright, looking over here at the graph of Shrek, again, we're going to pretend that the curvature of Shrek's head is defined by this green function, which is this over here. Again, we're going to start at negative 4.472 and end at positive 4.472. So these things here on the right, these are called your bounds, and the first number is your A, and the second one is your B. These bounds tell you where you start and where you end on the x-axis. So what does that mean? So again, we'll only look at the x-axis. In the first number, which is your A, will be right here, and second number B, which will be right there. To find the area underneath the curve, we have to integrate our function, right? But this is a special type of integration called definite integrals, which normal integrals, it will look something like this, right? You have your function and you integrate it, and your answer we'll get is a function and a plus c. Definite integrals are a little different because they add another layer where you have the normal integration, but then they throw in, boom, an a and a b right there. And it looks a little confusing, but it's actually quite simple because you just normally integrate it, and then afterwards, once you get your function plus c, you use a formula f of b minus f of a. Again, where this is your b and this is your a. So our function right here is y equals negative 1/5 x squared plus 5. So integral of negative 1/5 x squared plus 5. And this is a definite integral. So we evaluate it from our a, which is negative 4.472 to positive 4.472. So again, the first step to definite integrals is to just normally integrate it. Well, the integral of negative 1/5 x squared, we can ignore this coefficient and just integrate the x squared. So ignoring the coefficient, we add 1 to the exponent, and we divide by whatever number this becomes, which is 2 plus 1, which is 3, right? So this looks a little messy, but let's clean it up. We get 1/5 x to the 2 plus 1, which is 3, divided by 2 plus 1, which is 3. And this is 1/5 times this. So cleaning this up again, this will give us negative x cubed over 5 times 3, which is 15. The integral of 5 will give us the integral of any constant, which is just like a number by itself, right? It's like 5, 10, 20, 39, 72 will just give us that same number, and you just add an x, so 5x. And then of course when we integrate, plus c. But now the question is, where do these bounds go? We're not done yet. Now we add this little bracket and we include our bounds, 4.472, 4.472. And this is the part where we use that f of b minus f of a that I was talking about. And again, this is our b, and our a is on the bottom. So what is our f of x? This is our f of x right here. This is f of x, and this is f of b, and this will be f of a. So f of b, we're just plugging in our number b into our function. Our function negative, and our b is 4.472 cubed divided by 15 plus 5 times 4.472 plus c minus. Now it's important to put both these functions, when you evaluate both of them, put both of them in brackets here, because it helps with the distribution of this negative symbol. Again, we're plugging in, this is our f of b right here, f of b, and this is minus, and now we'll do our f of a, which will be negative 4.472 cubed divided by 15 plus 5, 472, and then plus c. Now putting all this in the calculator, you'll see that this comes out to be about 16.397, and you plus c, and then your brackets, and minus, this will turn out to be negative 16.397 plus c. Again, the reason we put both of these functions in brackets is to help the distribution of this negative symbol, because a lot of people forget that you have to distribute that negative. Again, distributing this negative to the negative 16 and the positive c, we'll get, just copying this down, negative times the negative will be positive 16.397, and negative times positive c will just give us negative c. The two c's cancel out, and we're left with 32.794. And we know that this is a correct answer because when we're doing definite integrals, again, it's going to be the integral symbol from some number a to b. When we're doing this, it will always result in some number. Normally, we're used to integrating, and then we get like some sort of function, and then plus c, right? But this is different. We'll get an actual answer in n. And this is the area of Shrek's face with some unit, which we don't know, but we'll just call it units. So we can conclude that the area under the curve, which represents Shrek's face, is this space in shaded green, and this area is 32.794.